Hello everyone to the sixth session of the AI Summit. In this session, we will host the talk of Amir, the founder of ECN, Easy Alumnis, and software and AI at BCG. The word is for you.
All right, thank you, Amin. Thank you, Amin. Hi, everyone. Yeah, thank you, Amin. Thank you, School of AI, for the initiative. I congratulate you on organizing this AI Summit. It's pretty impressive. I've been trying to follow some of the talks online. They are super technical and super impressive. And yeah, so I will dig in right into the content. Today's session is going to be lighter, right? It's not going to be super technical. The title of this talk is The 10x Engineer in the Age of AI. And it's just kind of sharing my vision about how the, let's say, development in AI is shaping our industry and how it's going to completely change the paradigm going forward of what it means to be an engineer and how you can prepare yourselves the best way possible to succeed in this world, right? Now, before digging into the content, starting with speaking about myself and why I'm here speaking to you, right? So first of all, I've sit where most of you are sitting right now, which is in the halls of Easy. I graduated from Easy in 2020, and then I did a master's in data science in Grenoble and CIMAG. And then most recently, I did also a generative AI executive program at MIT. So this is from the academic side. And then professionally speaking, I started with an experience in a startup at TSCR for a year, but then I've been working in consulting in the last 5 years between McKinsey and BCG, where I've been actually shipping AI products in different industries, in different geographies as well, including pharma, retail, banking, manufacturing across different geographies, as I said, so France, the US, Germany, Italy, Netherlands, Puerto Rico, and many other geographies as well. But also in the last 3 years, the main focus and the bread of butter and the butter of my job, was working on agentic AIs and actually building generative AI platforms, SaaSes, and working also on topics close to the AI regulation through the EU AI Act and how to put it into action to regulate the AI systems and make sure that they respect, let's say, the ethics of responsible AI. So this is a bit about me and what I've been doing in the last few years. Now, before digging deeper into the actual, let's say, deep content, let's define some terms. So what do I mean by a 10x engineer? So we can see it in 2 dimensions, right? We have the x-axis and we have the y-axis. On the x-axis, we have the breadth. And what I mean by the breadth is, let's say, the flexibility or the coverage and the deep understanding of different stacks. And what I mean by technology stack here, it's not just saying, do you manage React or Angular or whatever technology framework? It's more a full stack of being an engineer. So is it data science, software engineering, DevOps, MLOps, security, and so on, right? So this is the x-axis. The y-axis is the actual throughput. So what's the throughput that you're producing? Is it 1x, 2x, up to 10x, right? Usually, historically speaking, people were more often than not on the, let's say, the first quadrant, which are like, they start given, let's say, 1x normal output, and they manage only one stack. And most people will stay there for life. Excellent ones can gain more expertise and can have a better throughput. Those are sprinters that would have a better throughput, but they will stay always, let's say, specialized in one stack, and they will build expertise on that stack. On the other side, we have the polymath, which means there are people who will learn to manage the different stacks, and they will have deeper understanding of different stacks. But the throughput is going still to be 1x because they are, let's say, limited by the time they spend building things. And then right now, with the arrival of AI, we're getting into a world where those polymath people, those who have different, let's say, or a full spectrum when it comes to the breadth of skills that they manage. With the help of AI, they can have the 10x throughput. And this is where the 10x engineer comes, right? And what's important to understand here is that the throughput doesn't come at the cost of the quality. So the quality always stays the same or even gets higher while giving the 10x throughput. And this is super important to understand, because being a 10x engineer doesn't just mean that you are producing 10x of the output, but you're producing 10x of the output with the highest quality possible. Now that we got the term defined, so this is my goal for today's session. I aim to take you from wherever you are. So either maybe you don't use AI at all, which I highly doubt, or you are still using it, let's say, in a mode where maybe you speak with ChatGPT, you give it code and give you back code, or you're just using autocomplete, or maybe you're still, or maybe you moved into using agents. Whatever the starting point that you have, I'm going to take you into a journey where I'm going to share how the mindset have changed in the recent years. I'm going to change what are the new expectations, or share what are the new expectations in your role. Then the third thing is, how does this impact you in practice and how you can put it into practice while being tool agnostic, of course. And then the last element is the outlook on what's coming forward, right? And ideally, by the end of the journey, you would have a better understanding of what it takes to go from 1x engineer or whatever you are right now into an actual 10x engineer. So that's the journey you're going to be taking today. Now, before going into, let's say, the journey, starting with the shift, so sharing the mindset and starting with a quick history lesson. This was shared by Boris, who is the founder of KROUDIR, in one of the podcasts recently. But in 1440, Gutenberg invented the printing press, which is, you can think of it as, let's say, a basic printer, right? Or the concept of a basic printer. By then, scribes had the monopoly over the written word. So scribes are people, their job was writing things and copying things from books and so on, and rewriting them again so they can be shared and they can be published. By that time, the literacy rate was 6%. Decades later, what happened is that in the early 1900s, the literacy became up to 80%, and here we're taking Europe as a benchmark. And this was the result of, since the written word became commoditized through the printing press, more people started to get interested, and we had new jobs that came into light, right? We had publishers, we had people writing novels, we had people writing more scientific literature, we had, we had many new, let's say, roles that emerged. And the scribes who understood the system and moved into something new are the ones who thrived, and the ones who tried to stay, let's say, on the same basic scribe responsibility or the same basic scribing skills, those were replaced and they vanished, right? Now you may be asking yourself why I'm telling you this, where the analogy of what happened to the scribes and the written word is quite similar to what's going on right now with software engineering, except that for the printing press, it took maybe 300, 400 years. But for the software engineering AI, it's going to happen in a much higher speed. It can be a 10x speed, it can be 100x speed, because it's going to be happening in years and not hundreds of years. Now moving into the more recent history a bit, and speaking about the 6 ways of programming, what happened in the few recent years. With the arrival of ChatGPT and let's say the GPT 3.5, GPT-4, and so on, before they arrived, we usually used to write code by hand, which means we write all of the code ourselves. And then if we find the bug or we find the problem, we go to Google, we search on Stack Overflow, which I think maybe most of you know, but maybe some of you don't know, depending on your age. But Stack Overflow is a platform where people use to share like their technical problems, and people can put solutions and can upvote them. We'll try its solution by one until we find the solution to our problem. And this used to take us maybe sometimes days, sometimes weeks to find the solution to one bug, right? So this is before 2022. Then with arrival of better models, We had autocomplete at the time. We had GitHub Copilot, and we had other autocomplete solutions, but they are a bit basic, and they were not given any, let's say, significant productivity gains. By 2023, with the arrival of better models, we had better autocomplete. We started to use the autocomplete more and more, and it was more embedded automatically into our IDs and our workflows. Then by 2024, or maybe a bit even earlier, we started moving into IDs with chat coding embedded. It started with Cursor, then we had Windsurf, GitHub Copilot, and other IDs that followed with a similar implementation. From that, we moved into single agent systems with the arrival of Cloud Code. Cursor started to implement agentic systems as well. We had Codex and so on. Then from that, we moved into agent clusters, which means using multiple agents at the time. And this is where also we started to use Git work trees, which I think personally was one of the features that was the most underused before AI. And now with the arrival of AI, it's one of the most used features. So if you don't know it, the Git work trees allows you to create separate environments for your code base where each agent can work on that copy of the code base without impacting other agents, which means you can work on the same code base, you can have 6, 7 agents doing different things without them interfering with each other's work. So this was more or less, let's say, the end of 2025. And then by 2026, we are speaking about agent fleets and orchestration at scale. The most impressive, let's say, publication I've seen so far related to this is what OpenAI did, where they created a harness of agents that they let them write an internal tool. And in 5 months, without any human intervention, they wrote 1 million lines of code where they had the 0 handwritten codes. And the internal tool is actually finished and it's actually getting used, which is quite impressive. And I highly recommend you go read the article they wrote about it, because it gives a lot of insights into the harness and into the right mindset that you should have when you are building your own agentic workflows. Right. So this is what happened in the recent history when it comes to software engineering. Now, most people are still on the wave 2 and 3, which means they are either using the autocomplete, and most of them are using the chat coding, right? If you are on the tip of the spear, maybe you moved into single agent or multiple agent systems. But the good news is that if you are at the level of 2 or 3, you're not behind. Most people are still there, but you are not where the leverage is yet, right? So there is a lot of gains to be had if you move to the next level, which is using single agents and agent clusters. And this is what I'm trying to help you with today. Now, having a last slide about the shift or about the context, and speaking about more recent numbers. So what we know so far is that, and this is based on Cloud Code team, 4% of all GitHub commits come from Cloud Code. And this is in 2026, as of April 2026. And the forecast that it would arrive to 20% by the end of year, which is quite optimistic, which means 1/5 of the software is going to be written by one agentic platform, which is Cloud Code. Then at Anthropic as well, which is one of the leading companies in building foundation models for AI systems, and I think most of the people know, 90% of the code that they ship is AI generated. And some teams, for example, the Cloud Code team, 100% of the code for Cloud Code is written by Cloud Code itself, which is funny when you think about it. And then there is a third statistic that's a bit uncomfortable, but that gives, let's say, the full story of what's going on right now. 33% of developers trust AI accuracy, and it's down from 43% last year. These numbers are between 2024 and 2025. And what this tells us is that we are having, in one side, we're having more code than ever that's written by AI. On the other side, you are having the trust that's getting down in the AI written code, right? So the focus in the next few years is going to be on closing this gap between making sure that we, let's say, have more and more code written by AI because it's more efficient, while increasing the trustworthiness on that code. And that's going to be the main challenge in the next few years. Okay, so now we have spoken about the shift, what's going on, and I hope you're convinced that the actual job of software engineer and the actual job of computer scientist is going to shift drastically over the coming years. And now let's move into actually what are the expectations in this new world from you as computer scientists. And here, let me start with one of the quotes from Kent Beck, who is the creator, let's say, of test-driven development, and then of XP as well, which is extreme programming, which are two methodologies that are used a lot in the software engineering world. In 2023, which is more or less like almost 3 years ago, where the models were not even that good, he said that 90% of my skills that dropped to $0, and the remaining 10% went up 1000x. And a lot of people were asking themselves, which are the type of skills that went from, let's say, to $0, and which type went to 1000x. And he actually answered this 2 years later, where he said that the actual, let's say, skills that get up to 1000x are the vision, the milestones, complexity control, and knowing when you are done when it comes to building systems. And if you notice what's not there, it's everything related to the actual technical stuff of software engineer, like the syntax, knowing the APIs, writing boilerplate code, managing different frameworks, and so on. And then there is another quote that's super insightful as well, is that the friction is in your judgment, which means, and that pause when you think, is it right? Is there more than 500 lines of agent output? What these two quotes tell us is that the actual value is moving from the actual, let's say, having your hands on the keyboard and writing the actual code and doing the actual technical stuff, into the actual judgment and the actual vision of understanding, which is the long-term solution, let's say the long-term version of the product, the long-term architecture of the product, the different milestones when I'm building things, how to manage, let's say, the complexity of the solution, and also knowing when you are done, and knowing when you are done, not when you are done with the full solution, but knowing what are, let's say, the different cuts where you can consider it done. You can, let's say, save the work that you have already done and move to the next step. And what this means concretely is that software engineering as a proxy, and here I'm using it as a proxy. When I speak about software engineers, I'm not only speaking about software engineers, but I'm speaking about more or less a lot of the roles in the computer science realm, which includes data scientists, data engineers, data analysts, security engineers, and so on. So the role is fading, the role is changing considerably. And what's going to replace it is a mix of, let's say, these three dimensions, which are being an architect of systems, so understanding the full system and understanding how all the pieces fit together and how to link them together. Being an orchestrator of agents, which means you would have a proper workflow, a proper harness of agents that are going to be doing, let's say, the actual job and executing the jobs for you. And you're going to be orchestrating them, making sure they are going in the right direction, interrupting them where things are not going correctly, or setting them up in a way where if something, or they have some doubt, they would raise the questions to you. Otherwise, they can, let's say, proceed with some hypothesis that they can document. Whatever workflow you will create, they would respect, right? They're going to be an orchestrator of agents and then verifier of outputs. And here, when I say verifier of outputs, here it's not only, let's say, it doesn't mean reading the actual code all the time. Maybe now or initially we still read the code and verify it's actually sound and it's doing what it's supposed to do. But with time, verifier of output is going to shift from verifying the code itself into verifying the behavior itself. And here as well, the idea is that we're going to have a lot of tests set into place, unit tests, integration tests, end-to-end tests, and so on. That will allow us to automate huge portions of this work. And your job on the day-to-day is going to be, when it comes to verifying the outputs, it's just to making sure that the intent or what you wanted to build in the first place is respected. So just verify it matches your expectation and not that it works, because it would work out of the box. And now, what does this translate to when it comes to mindset is what I call the cheap executor, expensive advisor. So now what's going on is that the cheap executor is going to be the AI model, right? So the AI model costs way less than, let's say, human labor. And the expensive advisor is you. So what will happen is that the best setup for having disproportionate output is to have a fast agent that will manage the routine tasks, which is the cheap executor, and then your judgment for the hard decisions. This would equal the disproportionate output. Today, the cheap executor is going to be the model, the expensive advisor is you. But as we are moving forward and the models are getting better, what's going on right now is that we're having an additional layer where the cheap executor, the cheaper simple model, the expensive advisor, the smarter, most recent tip of the spear model, and then the human is even on a higher level as kind of like an executive or a chairman or a board advisor that will just direct on the high level, on the vision, on the taste, and what's worthy of being implemented or not. So now that we understood the expectation of the new role and how it's shifting going forward, now let's speak about some practical things, right? One of the things that I hear the most when it comes to using AI agents or using AI to do software engineering or to do technical work is that the models are unpredictable, and even with the same inputs with the same models, I can get different outputs across projects, right? And the main thing to understand here, whatever the tool you are using, whatever the technology, whatever the model, is that context is king. And what I mean by context is king, so if you give the model the best information possible, structured in the best way possible, and only the information that it needs, you will get the best quality of outputs. If your input, it's like looking for a needle in a haystack, it's not clear enough, there's a lot of, let's say, fluffy things around it and so on, you will not get the best outputs possible, right? And here there is some rule of thumb of things you can put into place. Usually, if you start to exceed 200K in terms of tokens in the context window of models, this is where you should shift into new discussion or compact that discussion. And every AI agent these days have a solution for either compacting and synthesizing a current discussion or taking the context from discussion into a next one, right? So this is the first, let's say, advice. And the second advice is to leverage any agent context files that will help your agent to understand your code base or understand what you are building without having to read a lot of information. So if you're using Cloud Code, it's your Cloud MD. If you're using Codex, it's your agents.md. It can be cursor rules as well if you're using cursor. So depending on the tool that you are using, you should always have either one or multiple actually Cloud.md or agentic context files that will give the AI the information about the code base without having to read the actual code and go look around in the code base. So this is one of the most important things, right? So the first thing to remember when it comes to practicality is that context is king. The second thing when it comes to practicality is the actual workflow, right? So when you are using these tools, you should have some kind of deterministic workflow that you will go through end to end to increase the chances of your system being as reliable and as predictable as possible. And this goes usually into first orienting your agents, giving it enough context about what you are trying to build and what you have built recently. The second is specifications, where you specify what you want to build. And here what you want to do is you want to use the plan mode. In whatever solution you are using, there's always a plan mode. And you want to plan through what you are wanting to build, right? Once you plan it, you execute that plan. And ideally, the agent that will do the planning should not be the agent that will do the execution. So this way you have separation of concern. And the two, let's say, agents will be separate with separate context, and they will not impact each other, right? So if an agent will do an error in the plan, if the executor agent will start freshly from that plan, the agent executor, since it doesn't have all the history before, it will not be, let's say, inclined into trusting the plan blindly, and it would review it initially to say if there is any loopholes or any problems, right? And the same applies into the step after that, which is the review step, where ideally you want to use an agent that will review what was implemented, and it should be a separate agent with isolated context as well. And then at the end, you can ship it, create a PR, document it, and this way you can you can validate your pull request, integrate the code, and move to the next step, right? So if there is, so here the second let's say advice is to use a deterministic workflow that goes step by step from capturing the intention, planning what you need to build, executing the plan, reviewing it, and then shipping it. And each step in this process is super important, especially the last one, where I think, and funny enough, I see this sometimes, especially with junior members, where they avoid having, super long PR descriptions that are clearly generated with AI agents, because they say it's clear that they didn't try this, and people are going to frown upon it and say, yeah, he just used some Cloud Code or Cursor or whatever to write this description. What you need to understand is you're not writing descriptions these days for humans, you are writing them for agents. So the more your pull request descriptions are descriptive and they have all the context needed, the better it's going to be in the future if you need to go back, understand what was built at some point without having to go deeply into the code. So this is the second practical 10. And now let's move into the third one. So here, what's important to take from this is that what's going on right now is that the spec is becoming the product and the code is the build artifact. And what we mean by this, so this was said by Ivan Turkovic, who was one of, let's say, esteemed engineers. So here, long story short, when it comes to the actual process that we have seen before, your main input is going to be on the specification side, so defining what needs to be built. Everything between designing what needs to be built, planning, execution, and reviewing should be seamlessly managed by the agents, and your workflow should be predefined and already rich with some skills, with some workflows that will enable you to go from a spec to a ready PR for review and for test, right? And you should not be the bottleneck inside those steps. And here there is an uncomfortable statistic that I put specifically on this slide. This comes from Google, and they said that with every 25% increase in AI adoption, they lose 7.2% in the stability of the systems. And this is an uncomfortable metric. Why is that? What you are seeing here with this statistic is that the more we leverage AI, the more we were putting, let's say, a trade-off on the system stability. So what's important to take from here is that there is always a balance to have, especially with the current capabilities of AI, to say to which level we are aiming to sacrifice the system stability, maybe with some percentage points. But on the other hand, you are going to be shipping way faster and driving value way faster. And then for some, maybe this will apply to some of your systems, but maybe for other systems, I don't know, maybe if you have some billing system that manage the payments, for example, and for that system, you would want to reduce, let's say, this instability, and therefore you would reduce or you would put more guardrails towards the AI adoption. And this is only today, right? So this is based on the model capabilities today. The models of tomorrow, I strongly believe that this gap is going to go smaller and smaller, and we are going to reach the world where this gap is going to completely vanish. Now, wrapping up with some of the advices that, let's say, super practical detail things that I would do if I was in your place today. The first thing is, whatever tool you are using today, write an agent context file. Is it your Claude.md, agent.md, whatever? Write your agent context file and see how your workflow and how your agents will improve after you do it. The second thing is to try to write one-page spec before your next feature. So before going directly to build, try to write one-page spec saying, this is what I want to build. These are the acceptance criteria. These are the edge cases, just to see how the exercise will go. The third thing is having a reviewer sub-agent, because this is something that I think a lot of the teams don't do and a lot of people don't do. while it's one of the highest leverage agents you can have. Because if you already have a reviewer agent that will do the work that you always do, for example, you always check for specific things. You always check that all of your imports are up in your files. You always check that your functions maybe does not exceed 50 files each, 50 lines each function. You always check, for example, that the new code is properly tested with unit tests and so on. If you have a sub agent that will check all of those things and do the fixes already, you already gain time, because when you yourself start reviewing the code, all of those things will be fixed, right? The fourth thing is, and I would highly encourage doing this, is try to build something out of your stack. So if you are, I don't know, you are a software engineer, go build a data science pipeline. If you are a data scientist, go build a website. If you are a web developer, go build a mobile app, just to see how you can take the, let's say, the capabilities and the, let's say, the hard skills that you have gained from your own craft and your own stack, and applying them while leveraging AI to a different stack. And the last one is ship something every week. And here, what I mean by ship something every week is not just shipping, but also reviewing your workflow every week. If I speak about myself, my workflow and my setup when using AI agents today is not the same from 2 weeks ago, and it's not the same from January this year, and it's not the same from last year, right? My setup is evolving more or less every 2 weeks. And this, let's say, this development happens because I'm trying to ship things every week, and let's say I diagnose my system and I think how I can improve it and make it better. I see what's going on around the community, and then I iterate on my system every time. All right, now moving to the last step and looking forward. Maybe some people, after, let's say, seeing all of this, are going to be panicking a bit, maybe questioning their life decisions, maybe thinking, is computer science even worth it? Is software engineering even worth it? And so on. And let me reassure you, software engineering is here to stay. Just the role is changing, right? And where the demand is not going to be for the same level or the same type of software engineers. We're going to have more generalistic engineers, but the demand for those are increasing. And we have statistics that there is plus 11% software engineering jobs year over year in 2026. And then there is a quote as well that's super interesting by Bosch that says, this is the third golden age of software engineer. So, and I strongly believe that this is the actual third golden age of software engineering, because with the AI right now is unlocking a lot of the value and a lot of, let's say, of the capabilities that building software that has never been, let's say, easier, and which means maybe some of the problems that were not worth it to address before, it's worth it to address them today. And therefore, the demand for this type of skill sets will increase even more in the next few years. The second thing, looking forward, so there is an interesting quote that I read recently as well by Steve Yugi. I don't know if I'm pronouncing this right, that has more than 30 years experience in engineering, but he said, you must only get 3 productive hours from someone by coding at max speed, but they are 10x as productive. So do let them work 3 hours? And the answer is yes, right? So with the AI engines managing a lot of, let's say, the actual execution of the plans and the actual execution of what you want to build, you may need to spend less and less time on the job, right? And that's totally fine. If you are spending 3 hours steering your agents while arriving to the 10x or 100x outputs, that's totally fine. And that's better than having or being an engineer that works for 8 hours but produce at a 1x speed, right? So the bottleneck is shifting from hours at the desk into the quality of attention, and also into the token budget that you would have, because the token budget is not unlimited, of course. Right? Now, the last thing I wanted to speak about, which is relevant for, I think, for our audience, is that today, and especially today, the different geography is no longer a barrier. So everyone in this world with laptop, with internet connection. They have access to the same tools, same models, same technology. So the barrier has never been, let's say, smaller, and it's, let's say, your time to shine. It's your time to show your skills and to take your place into the market without thinking that I come from this geography or I come from this geography, so maybe I'm not that attractive into the job market, right? So with the current technology, the barriers are getting smaller and smaller. So yeah, so I hope through this journey, I managed to get you from, at least in terms of mindset, from whatever you started into becoming a 10x engineer. And I would like to finish with one question. So if the tools are the one who write the code now, what do you write? What do you do? And the answer is the spec, the architecture, the different or the difficult judgment call at 2 a.m. of what should be built and what direction to take, and the things that the model can't look up. Everything else should be done by your AI agent. Thank you very much. And we can move to the questions.
Thank you, Amir, for this interesting talk. These were such interesting informations. I think that's such important for every engineer in this era to know how to use agents and AI to leverage the code in this as soon as possible. Personally, before answering questions, I have a personal questions. I mean, here at Easy, most first and second year students are divided into two parts. I mean, there are some students that rely entirely in AI stacks. Like, I mean, they don't know anything about the domain. But in the other side, we find some students that are breaking in the basics of programming languages. I mean, what do you think about this? Should we rely entirely on stacks, or there is such balance that we should aim for? What's your opinion?
Can you repeat the question, please? I lost you for a second.
Sorry, I said that here at Easy we find that the most so many students of the first year and the second year are divided into two parts. I mean, some rely entirely in AI agents and the copilots and such things, but in the other hand, we find that the other students are stuck in the basics of programming languages. I mean, they say that they have to understand, they want to understand the thing from details. What do you think about this? Should we rely entirely in AI, or there's some balance that we should aim for?
Yeah, here is my recommendation. So the answer is the following. The answer for me is that you should, let's say, prioritize what you delegate to the AI and what you don't delegate to the AI, right? So for example, the syntax is going to be useless in the future, and you don't need to know the syntax. I myself, I'm writing, like, I wrote complete platforms in TypeScript, and I never wrote TypeScript in my life, and I never learned the syntax of TypeScript in my life. And the platforms are deployed at production, at clients, and they're actively using them, right? So to go back to the question, you should prioritize what you delegate and what you don't delegate. So the syntax, for example, is low value. There is no need to learn the syntax. Of course, you should be proficient at least in one language to know how things works and so on. But beyond learning one language, any other syntax you would learn, that's not necessary. Unless it's a new paradigm. So for example, you want to learn dynamic programming, so we would learn let's say the programming paradigm, or you want to learn the design patterns, or you want to learn some system architecture. That's are the things that are worthy of learning and understanding. But the syntax itself, that's something you can delegate. On the other end, what are the things that are high value and you should not delegate? That's the problem solving, the algorithmic approach, how to estimate the complexity of your algorithm, how to optimize your algorithm, how to properly test it, what are the edge cases. So the problem solving and thinking about the complexity and doing the actual thinking, that's the thing that you should not delegate to the AI initially to build that skill. But you can use the AI to be a sparring partner, to discuss with the AI, to say, this is my approach. what are the loopholes. You can challenge the AI can challenge you again and again, and you can use the AI as a sparring partner to craft that skill. But you should not delegate it to the AI initially. So that's my take.
Thank you. I think that's such a valuable answer. I mean, yes, we should focus in the basics and learn the program, learn the concept before, and then we can rely on AI to complete the work that needs time. We have another question from the chat. Do you think that the generative AI adoption is the reason behind the companies not recruiting and they use cloud codes to automate anything, and they do not need any developer to do the soft things?
Yeah, I think, to be honest, I would be lying if I say it doesn't impact. I think it definitely impacts. So these days, it's yeah, I mean, the AI agents are at the level where they can do most of what a junior, let's say, engineer out of school can do, without the human part, of course. So anything related to client interactions and so on, they will not be able to do, of course. But when it comes to the technical things, building stuff, most of the AI agents are on the same level or even better than most junior people, right? And this is why you should shift into competing in other areas. You should not compete with AI agents being proficient at software engineering, but you should be shifting your focus into competing in other areas. So being a more complete profile, having a business sense, having solid communication, having good taste of what should be built and so on, having a full, let's say, full stack builder skill set around you that will make you not compare. So the AI is always going to be better than you in writing code, but as an asset, you're going to be way more complete and way more, let's say, appealing that the company would like to hire you, right? So to answer the question shortly, yes, definitely it impacts, but that doesn't mean there is no junior jobs anymore. There is always junior jobs, but there is a lot of pressure right now where the jobs are maybe less. Companies are looking more for more senior engineers, and even senior engineers these days, they would rather have, let's say, increase their token budget than hire an intern. Because with the token budget, they can get way more done than hire an intern. But on the long term, of course, hire an intern, they will like going to be coaching someone which will evolve in the company later on down the line. But I mean, that's something that's going on in the workplace right now. And this is why these types of stocks is important, because it gives a reality check of how the job market and how, let's say, yeah, the job market is changing and how it's shifting, and how you can anticipate from now and build your profile and build your skill set in a way that even if the AI is going to get 1,000 times better in the next few years, your skill set is going to be still relevant and still demanded in the job market.
Thank you, Amir, for this answer. This is Alan. So someone is asking, do you think that using generative AI is the reason for having jank code? I mean, some persons think that the AI is the reason for having some code that's not. I mean, a code that it's not optimized, that we can write it in, that the human can write it in a better way. What do you think? Do you think that AI is capable of writing the code of a code of high applications in optimized way? I mean, not just in writing code, but reasoning in a high scale and understand the full system. What do you think?
Yes, I think, yeah, let me rephrase the question just to make sure I heard it, because I lost you for a second. So the question is that, do I think that generative AI can write actual complex code for complex problems that's actually well optimized like a human, let's say, engineer can do, right?
Yeah, that is.
All right, makes sense. So yeah, so I will tell you what I think, then I will give you examples, and then I will let you search for yourself. So what I think personally, I think the AI completely does, and even when it doesn't, it's a matter of context, right? So if you give the AI a problem and then you explain the problem concretely, you get for a solution. If the solution is not optimized, you can always challenge it and ask the AI to propose different ways of doing it. And the AI will propose the different ways of doing it, and then you can implement them, test them, and you can use the AI itself to write hundreds of tests to test how the algorithm is optimized. And then once you're confident with it, you would deploy it into production. So the AI can do this in a way faster way with your steering and your, let's say, you pushing the AI in the right direction. So the short answer for me is yes, it can. The example I wanted to share. So last week, I actually attended into OpenAI event here in Paris by Codex team. And one of the people in the Codex team, they shared an actual really complex problem that they work on during their vacation. And it was an algorithm of taking a picture, turning it into a black and white line style picture, like just like black and white and like it's drawn by line. And then having the algorithm where you can color this image by pressing into like every object that's closed and so on, and coloring it with one color. If you think about it, the problem is super complex, and Codex was able to do it. After what he did is like he ran 100 agents of Codex doing it in this, like in parallel, and like 7 or 8 of those solved the problem. So you can see that even for the most complex problems, agents are able to optimize them. And then the second example I can mention, so I read this maybe a bit like, let's say 1 month, 2 months ago, but Anthropic have published papers about how they are using their own models into optimizing the inference for the newer models, right? So they use 4.6 for optimizing the 4.7 survey, for example. So they are already leveraging older models to optimize the new ones. So it's super complex problems. It's definitely problems that were not seen before, because it's like 4.7 didn't exist before, but still AI can help with that. With this being said, if AI is used in the wrong way, so if you're just throwing the problem without like the needed context, without, let's say, giving any constraints and so on, of course the AI is going to give you the dummiest solution possible, because the AI will act more or less like a human, right? But if you give it many constraints, you give it more directions, you would iterate with it all the time, you will let it write tests and test again and again, you would always arrive into an optimized solution, and it can be a collaboration between you and the AI.
Thank you. I think that all it's well said. Just the last question from chat. Since you have talked about Codex, what do you think about using such powerful agents like Codex, Cloud Codes, and so and such on? Uh, about the privacy concerned. I mean, we have in the past week or past 2 weeks, we have find that Cloud Code was leaked, and we can say that all kinds of privacy can be leaked at this time. So what do you think about the security and privacy concern when using AI agents?
Yeah, so here, so let me be completely transparent, right? So there is 2 things. The first thing, let's say the formal answer. If you're working within a company, and then that company will get an enterprise license of Cloud Code or Codex or whatever solution, usually there is, let's say, a contract between your company and Anthropic or OpenAI about the security measures put into place and so on. But there is always risk of things getting leaked, and that's a risk that it can never be risk zero. Right? Doesn't mean you would not use the technology. For example, email, we use it every day, but email can be leaked as well. Credit cards, we use them to pay every day, but they can be hacked as well. So there is like a lot of technology we use every day. It can still be hacked, right? So there is no risk zero, of course. And usually when you are working with a company, there is things that are put into place to make sure that your data is protected, and there is many, many layers of security, but it would never be risk zero. So there is this on one end. Then on the second end, if you are a student trying to learn and trying to do things, most of probably you are not working on like some secretive, high security problem that if OpenAI or Anthropic will get it, some country in the world will get destroyed or something, right? Or some war will start. You're working on some, let's say, maybe project related to your school or some freelancing projects. And worst case scenario, even if it's leaked, it's not the end of the world, right? So I would highly recommend using them, trying them, testing them as much as possible. Because if you don't, let's say, grasp how capable they are. And if you don't grasp how capable they are, you will not understand. And when the shift will happen, so once they will, let's say, because like in the recent few months, not years, the jump was actually like going from 1x into 10x. Like before, and this was said by Andrej Karpathy recently in a talk. So he was the head of AI at Tesla, and he's one of the pioneers in the AI space. He was actually one of the founders of OpenAI, or he was one of the first engineers at OpenAI, if I'm not mistaken. And he was the inventor of the term vibe coding. So he's, I think most of the people maybe in the audience know him. But what he said recently, and I actually witnessed that, by December 2025, something happened in the models where initially you had to do a lot of hand holding and pushing the models in a certain direction. But what happened in December 2025, the models that happened, like that arrived after there, most of the time, you don't need to review the code. Most of the time, it one-shots the task and you move to the next one, right? And this is where, for example, if I speak about myself, maybe not starting then, it started to happen gradually. I started using, by that time I was using Cursor. So using Cursor all the time, validating every edit, accepting every edit manually, and so on. But early this year in January, I switched to Cloud Code, and I started putting agent skills and putting like actual harnessing around my agents and so on. And once I did that, let's say my throughput went from maybe 5 PRs a week into 50 and beyond. And I have a week where I shipped 100 PRs in a week, because I always have 8 to 10 agents working on different things, and all of them, most of the time, they one-shot the task, and I just need to test, make sure it works as expected. I check the PR, and then I submit it for approval, and then it gets merged and deployed.
Sincerely, thank you for all your answers. I mean, like, in this event, so many persons have talked about AI agents. So some persons have talked about the research side, some other persons about the engineering side, but you have talked about the productivity and how to use AI agents in everywhere. I mean, in every field. So thank you very much. We have just I think this is like last question from Yusuf. He says, what do you think about keeping updated with AI tools and AI agents tools and models? He thinks that whenever a chance to learn a new tool, another one will appear. So what do you think? Should we stay updated or master old ones, or what do you think about this?
Yes, I think definitely you should stay updated, and it's linked to the one that I answered right before this one, right? So I know the tools are changing all the time, but if you're not using them, you're not grasping the capabilities of what they can do, right? And if you jump from, let's say, if you jump from the model capability from 1 year ago to today, the shock is going to be too abrupt that you will not understand, you will not know how to use the tools. It's too powerful. It's kind of like moving from riding a bike into riding Formula One. So like the difference is too big, right? But if you're riding a bike, and then we had the first car, and then you ride the first car, and then we had the better car, and then we had the better car. And every time you are riding on that one, getting used to it, getting used to the speed, once we have a rocket, you are already riding on on a plane or on like a fighter jet, right? So moving from fighter jet to a rocket speed, you're already there. So the difference is not going to be too steep and you're going to grasp it quickly. But if you come from, let's say, riding a bike, the difference is going to be too much, right? You can be shocked. So I highly recommend staying up to date. I highly recommend experimenting with the tools as much as possible. And not everything will stick, right? For example, MCPs, at some point they were kind of like the religious thing. Everyone was speaking about MCPs. Now, not everyone is speaking about them, and CLIs are the next thing. Skills, for example, there is, let's say, billions and millions of skills online. A lot of them, sometimes they have a lot of hype. They have like 100K stars on GitHub. But when you test them, you would see that it's not actually driving any value, right? But you must test them. You must see how it fits into your workflow and decide if it works and if it doesn't, right? So to summarize, definitely you should stay up to date. Definitely you should experiment, and always make sure that even like if you have a perfect workflow, as I said before, always after 1-2 weeks, try to review it and see how to optimize it with the latest tools, because what worked 2 weeks ago will not work today, and so forth.
Thank you, Amir. Such a pleasure. I think that was like last question. I want to thank you. I think School of AI Algiers has the honor to have you on this such event. Thank you very much for all these informations. You have give us such valuable tricks and steps how to use AI to leverage high level code. Thank you very much for this talk, Sahid.
All right. Thank you.
Merci.